So, hello students. Again, we are continuing with our BITSAT 2026. So, quickly we will do the questions. Okay, now we are coming up with the first question. Just see, they are asking how many coulombs of electricity are required for reduction of 1 mole of MnO4 minus, that means to Mn plus 2, right? And they have given options in coulomb, so they are asking answer in coulomb, okay? Not in Faradays, in coulomb. Just see, they are, you will be asking in which medium. Keep in mind when MnO4 minus changes to Mn plus 2, it is always in acidic medium. If MnO4 minus changes to MnO2, then it is basic medium or neutral medium. Okay, now we are coming, now we have to, what we have to do, we have to first balance the equation. Can you see the balanced equation? Can you see the balanced equation? Okay, there are +1 charge this side, then +8 charge, then +2 charge. So how many electron change? It is 5 electron change. Can you see? You are having 5 electron change. Okay, so basically 5 electron, this equation is not 5 electron, it is basically 5 mole of electron. 1 mole of KMnO4 reacting with 8 moles of H plus, taking 5 mole of electrons. So 1 mole of electron has got charge to be 96500 and the credit goes to Faraday. This work was done by Faraday, just such a simple work. He calculated the charge on 1 mole of electron. 1 electron we were knowing. Then he calculated for 1 mole of electron and it is 96500 coulomb. So we are requiring 5 electrons. So we need 5 Faraday or simply 5 into 96500 coulomb. That is, the answer will be 4.83 into 10 to the power 5 coulombs. Getting my point? So balance the chemical equation, calculate the electron change and give the charge on electron responsible for this reduction process. Okay, now we are coming up with the next question. Okay, now this is the question coming up on the topic electrolysis, right? What is electrolysis? Basically, it is breaking of a compound by passing electricity through it. So how you will be doing this such questions? First, ionize the compound and just take to respective electrodes where they will get discharged. And keep in mind, if the species is moving to cathode, it will get reduced. And if there is a competition between two species getting reduced on cathode or getting oxidized at anode, then you have to consider standard reduction potential. What you have to consider? Standard reduction potential. If standard reduction potential is high, reduction is favorable. And if it is low, then oxidation is favorable. Can you follow this? So, who will win the competition at cathode? The one which has got high SRP. And who will win the competition at anode? The one with low SRP. Keep this in mind. Product of electrolysis depends upon many factors. Nature of electrolyte, then concentration of electrolyte, then nature of electrode, current density, and to some extent over voltage also. Okay, now just see, they are asking about dilute H2SO4. Now in case of dilute H2SO4, if you ionize, okay, then it is H plus ion, HSO4 ionized along with water. We are having water also, aqueous. Okay, aqueous medium है तो water भी है competition में. Okay, but see, water is also having H plus and acid is also having H plus. So we have non-controversial obtaining of hydrogen at cathode. So we are getting hydrogen at cathode. Okay, now we are coming to, this is your answer for cathode. Now we are coming to anode. Now at anode, oxidation take place and we have got two reactions. One is of water. Oxidation of water always gives oxygen, and what oxidation of sulfate will give you, what is this ion? Peroxo disulfate ion. Okay, and just see, I have written down the SRP values also. For water, it is 1.23. For sulfate, it is 1.96 volts. It is too high, right? Even if we consider over voltage, then also, who is the winner? It is basically oxygen. So we are getting cathode pe hydrogen, anode per oxygen. Okay, just see the options. No, this is not the option. This is not the option. Now they are saying at anode and cathode respectively. So this is your option. Can you see? Oxygen at anode and hydrogen at cathode. Just see the last option. Don't be in a haste. H2 and O2. You just recall H2, H2, H2. No. They are saying anode and cathode, they are asking respectively. Okay, so your correct answer will be this. Now see, we are coming up with the next question. It is from physical properties of haloalkanes. Okay, physical properties of haloalkanes. And keep this in mind, in physical properties, no net chemical change, only physical forces, right? Then we will ask you about the interparticle forces or packing or volume, whatever. Okay, they are asking about which one of the following has highest boiling point. Keep this in mind, when we are talking about boiling point, it only depends upon interparticle forces. Now, what are interparticle forces in haloalkanes? First of all, we are having dipole-dipole. Can you see? We are having dipole-dipole. But it is common in all, right? So, we are coming to the next consideration, which is not the dominant force, but in this case, we have to consider, and that is van der Waals force. ठीक है, एक फोर्स इंटरपार्टिकल फोर्स कॉमन है सब में, तो सेकंड अपना पॉइंट ऑफ कंपैरिजन रहेगा, जैसे कि हम डिक्शनरी में जब पहला वर्ड कॉमन होता है तो दूसरा देखते हैं. ठीक है, सो नाउ वी आर कमिंग टू व्हाट van der Waals forces. Van der Waals forces are universal forces. If there are no forces seems to exist, but definitely van der Waals force will exist. Okay, they are universal forces, directly proportional on surface area. More is surface area, more is van der Waals force. Something which is going circular, surface area उसका सबसे कम होगा. ठीक है, then molecular mass, it is also directly proportional on molecular mass. In all the four cases, the molecular mass is same because they are isomers, but their surface area is different. Can you see? This is having maximum surface area. It is having branching. It is having branching. It is also having slight branching. So your answer will be first, which has got maximum van der Waals forces. So maximum interparticle forces. So maximum boiling point. Okay, so this is the way you answer this question. Okay, now we are next coming to our very easiest of easy question. Now we are coming on another named reaction, which is fatigue reaction. And what is the beauty of this reaction? Basically, if we learn one reaction, we can learn 3 named reactions, and we love to learn it. Why? It is one of the easiest and most important reaction, Woods reaction. 2 halo compounds reacting in presence of sodium and dried ether to form a higher alkane. Alkyl halides reacting to form higher alkane. Then again, this experiment was actually conducted by Woods, and another scientist, Fittig, actually took aryl, aromatic compound, aryl halide, and performed the same reaction, and what they obtained, similarly they have got higher aromatic hydrocarbon as diphenyl. Okay, now if they work together, then if you take one alkyl halide, one aryl halide, again you are getting a mixed aromatic compound. Now what is this? See the options. Reaction between 2 aryl halides in the presence of sodium and dry ether, this is the correct option. Reaction between 2 alkyl halide is basically Woods reaction. Reaction between an aryl halide and its Woods-Fittig reaction. Okay, but this is not the or any of the 3 because it is taking iron, which is not an active metal. Okay, which is not an active metal. So your answer will be A. Okay, followed.